Welcome to EMR Physics. I am Raju, NCERT 12th Physics. We are solving the numerical problems given in Chapter 8, Electromagnetic Waves. In this video, we are going to see how to answer the question number 8.9. The question is, the terminology of different parts of the electromagnetic spectrum is given in the text. Use the formula E is equal to h nu for energy of a quantum of radiation photon and obtain the photon energy in units of electron volt for different parts of the electromagnetic spectrum. In what way are the different scales of photon energies that you obtain related to the sources? This is a given question. In this question, we are asked to use the formula E is equal to h nu. By using this formula, we have to find the energy of photon corresponding to different wavelengths of the electromagnetic spectrum. Next, we have to answer the question how the different photon energies can be related to the sources. Let us see how to answer this question. First, let us see how to calculate the energy of a photon. Energy of a photon can be calculated by using the formula E is equal to h nu. Here E is the energy of the photon, h is the Planck's constant and nu is the frequency. Nu can be written as c by lambda. This is from c is equal to nu lambda. Here c is the speed of electromagnetic wave in free space. We know the value of c. Therefore, E is equal to h c by lambda. H is the Planck's constant. Planck's constant is equal to 6.63 into 10 to the power minus 34 joule second. C is the speed of electromagnetic wave in free space. C is equal to 3 into 10 to the power 8 meter per second. Therefore, E is equal to H is 6.63 into 10 to the power minus 34 into 3 into 10 to the power 8 meter per second divided by lambda. If we multiply these two, we will get this is equal to 19.89 into 10 to the power minus 26 divided by lambda. So this is the energy of a photon and this will be in joule. This can be converted to electron volt by dividing this by 1.6 into 10 to the power minus 19. That is the charge of the electron. If we divide this 19.89 into 10 to the power minus 26 divided by 1.6 into 10 to the power minus 19. Here we are having 1 by lambda. We will get the energy in electron volt. So this is equal to 1.24 into 10 to the power minus 6 into 1 by lambda electron volt. So this is the energy of the photon having wavelength lambda. This is the energy of the photon in electron volt. By substituting the value of lambda, we will get the energy of photon in the electromagnetic spectrum. Let us see two examples how to calculate the energy of photon corresponding to two waves in the electromagnetic spectrum. Already we have calculated the energy of the photon. The energy of a photon can be written as E is equal to 1.24 into 10 to the power minus 6 1 by lambda electron volt. So by knowing the value of lambda, we can calculate the energy of the photon. In the electromagnetic spectrum, there are different rays. Different rays have different wavelengths. By substituting the corresponding wavelengths, we will get the corresponding energy of a photon. Now let us see two examples how to calculate the energy of a photon for gamma rays and visible light. For gamma rays, lambda is equal to 10 to the power minus 12 meter. Therefore, E is equal to 1.24 into 10 to the power minus 6. Let us substitute lambda is equal to 10 to the power minus 12. In this formula, we will get 1 divided by 10 to the power minus 12. So this is equal to 1.24. Here we are having 10 to the power minus 6, and in the denominator we are having 10 to the power minus 12. When it goes to the numerator, it will be 10 to the power plus 12. So plus 12 minus 6 is plus 6 into 10 to the power 6. This is the energy of a photon in the gamma rays. The unit is electron volt. This can be written in million electron volt by dividing this by 10 to the power 6. So this is equal to 1.24 million electron volt. Similarly, let us calculate the energy of a photon in the visible light. For visible light, let us take the average wavelength. Lambda is equal to 5 into 10 to the power minus 7 meter. This is the average wavelength. Approximately lambda is equal to 5 into 10 to the power minus 7 meter. Therefore, E is equal to 1.24 into 10 to the power minus 6 into, let us substitute the value of lambda, 1 divided by 5 into 10 to the power minus 7. If we do the calculation, we will get this is equal to 2.48 electron volt. This is the energy of a photon in the visible light. In the electromagnetic spectrum, there are different rays. Different rays have different wavelengths. By substituting the wavelengths, we will get the corresponding energy of a photon in the electromagnetic spectrum. Now the question is how we can relate the different energies to the sources. Let us see how to answer that question. The next question is how we can relate the energy of a photon to the source. Before going to answering this question, let us understand how the photon is emitted by a source. Let us assume that these are the two energy levels of a particle. These are the two energy levels of a particle in the source. This is the lower energy level, which is taken as E1. This is a higher energy level and it is taken as E2. So this is a lower energy level and this is a higher energy level. So E1 is lower than E2. These are the energy levels of a particle. Here the word particle means it can be an electron or a nucleus or atom or molecule. The particle is in the source. Suppose if the particle is making a transition from higher energy level to lower energy level. That is, the particle is moving from higher energy to lower energy. The difference in this energy is emitted and it is known as photon. So the difference between these two energy is E2 minus E1. This is emitted as a photon. The photon is nothing but the quantum of energy. You can easily understand that when a particle moves from lower energy to higher energy, it absorbs the energy. When it moves from higher energy to lower energy, it emits the energy. The emitted energy is known as photon. So the energy of the photon depends on the difference between these two energy levels. If the difference between these two is more, then the emitted photon will have more energy. If the spacing is less, then the emitted photon will have less energy. So from the energy of the emitted photon, we can understand that the spacing between the energy levels of the source. So from the energy of the emitted photon, we can understand the spacing between the energy levels of the source in which the particle is making the transitions. So from the energy of the emitted photon, we can understand the spacing between the energy levels of the source. We have already determined the energy of the emitted photon in gamma rays and visible light. The energy of the emitted photon in gamma rays is equal to 1.24 million electron volt. This is for gamma rays. Whereas in case of visible light, the energy of a photon is E is equal to 2.48 electron volt. This is in case of visible light. So this is more and this is less. Hence we can say that the spacing between the energy levels of the source which is making the transition is more. Here the spacing is more. In this case, the spacing between the energy levels is less. So this is a relation connecting the energy of the emitted photon to the source. This is the answer for the given problem. If you find this video is useful, please subscribe the channel, share it to your friends. If you have any doubts, comment below. Thank you for watching this video.